We want to look now at sampling variability, and the idea about sampling variability is how much do our samples vary. So we can talk about between one sample, comparing one sample with another, do we get variation, and also even within a single sample, how much does my data vary. So if I'm looking at the heights of Year 13 students in our class, why are not all of our students exactly the same height? Why is there variation? So that's the idea of sampling variability. So this diagram talks about looking at all these different samples, and you can see there when we take a different sample, each of these box plots is going to be slightly different, okay? And that's because you're going to collect different data from different people, get different medians, and all of these things. So if I took another sample, this is the key starter that you can use. If I took another sample, are you going to get the same data? No. So if we're talking about the rugby players and we're talking about the weights of our forwards and our backs, are we going to get exactly the same players that we choose if we take another sample? No, we're not. We would get a different sample with different players. So the data is not going to be exactly the same. What about our median? What about our upper and lower quartiles? What about our minimum, maximum, our standard deviations into quartile ranges? Are they going to be the same? Well, no. We've got different data. We've got different people in our sample, so it can't be exactly the same. But is the median going to be a similar? So the median weight of forward players, are they going to be similar, or would they be quite different? Well, I would expect that they would be similar, okay, because back in our population, that's what we're looking for, is our sample should represent the population. So what about our confidence interval? Are they going to be exactly the same? No. Our confidence interval is going to be different because we've got different data, we've got different people, so we're going to have different values in there. But is it going to be similar? Yeah, it should be similar to what we've got now. So that's our key ideas between if I took another sample, and you need to be able to write those up talking about your data that you have, not just if I took another sample, I'd have different data, different medians, and a confidence interval that would be similar. That would not be sufficient. It has to be talking about in context. So if I took another sample of rugby players, I'm going to get different people, so I'm going to get different weights. Therefore, and explain that more. What about our conclusion? Well, if I've got enough evidence to make the call, then I'm probably still going to have enough evidence to make the call with another sample. If I didn't have enough evidence to make the call, then taking another sample is probably still going to give me the same conclusion. So our conclusion is likely, not guaranteed, likely to be the same. Now let's take a look at this idea of accuracy. So when I've got these two graphs here, which of them has a smaller spread and which one is more accurate? The graph on the left here is more accurate. There's a lot more data in the center. So there's a lot more data values packed closely together, so there is less spread, less variation. So that means that graph is more accurate. The other idea, if I took a bigger sample, think about, would your data be the same? Well, no. If I've got a bigger sample, I've got new people and more, so I've got different data. What about your median, your upper and lower quartiles? Are they going to be the same? Well, your median's likely to be similar. Not guaranteed to be exactly the same, but likely to be similar. Our upper and lower quartiles might move a little bit though, and I'll come back to that idea. So let's think about our confidence interval. If I've got more information, if I know more about something, I can be more accurate. If I'm more accurate, let's go back to this graph there, if we're more accurate, the spread of the data is getting smaller. So our confidence interval is likely to become smaller. The width of that confidence interval is likely to get smaller because we've got more information and we're more accurate. What about our conclusion? Well, for our conclusion, if I had enough evidence before, then I've probably still got enough evidence. If I didn't have enough evidence, maybe now I have got enough evidence to be able to prove that there is a difference between them. So our confidence interval may change depending on what the conclusion was before.